Okay, we now move to theorem 3, part 3 of the video, and then it is given that if an arc subtend an angle at the center of the circle. If an arc, this is an arc we're talking about, arc GF, if it subtend an angle at the center and at the circumference, the very same angle at the circumference, so the very same arc, this arc, it subtend this angle and it also subtend this angle according to the theorem. If, right? And then the angle, now the statement says the angle at the center, it is now twice the size of the angle at the circumference. In short, they'll say angle at the center, it is 2 times angle at the circumference. So now we need to prove that the angle at the center, it is 2 times the angle at the circumference. So the first thing when we prove, we're going to do is we're going to construction. Based on the construction now, we're going to join HO and produce, that are supposed to be produce, and produce K, right? And produce K. So now let's join the line that we're talking about. Talking about line HO. Let's construct it. We have line HO, and then we have produced K. Okay, then we're going to have our K to be here. Okay, going to have our K to be here. So okay, let's call this O1, and then this 2, we have H1 and 2. So we can now start with our proof. So okay, before we even go far, let's say let our H1 be equal to X and H2 to be equal to Y. Just trying to make our life easier. Then we have that, right? Trying to make our life easier. Okay, so now let's look at the first, I'm going to highlight it. Let's look at this triangle. Right, that will be triangle OHG. Looking at triangle OHG, we can say H1, we can say H1, that will be equal to G, and that is equal to X. What will be the reason for that? Will be angles opposite, and then equal. You can say equal side or equal radii. That is still fine. Equal side, or you can use radii. You can use radii. Okay, so looking at it again, we have O1, which is the exterior angle of the 2, exterior angle of H1 and G. That means that our angle O1, it is equal to angle H1 it is O1 is equal to H1 plus angle G, and then that will be, remember, H1 and G both are equal to X, then will means we're going to have X plus x to be equal to 2x. So now the reason for that will be the exterior angle, of triangle OFG. Now looking at another triangle, that will be triangle OHG. Right. Okay, so we're done with the first triangle. Let's look at the second triangle, which is triangle O, HF. Now looking at the triangle, it is similar to triangle OHG. Then we're going to do the very same thing in this case. However, we have H2. Am I right? So now we're going to say H2. We're going to say angle H2, it is equal to angle F, and then there it is equal to Y. Okay, what is the reason? The reason will be angles opposite equal side. Angles opposite equal sides. So now looking at angle O2, angle O2 is this one. That is the exterior of angle H2 and angle F. Then O2, it is equal to angle F plus angle H2 plus angle F, which that is going to give us Y plus Y. Remember, angle H2, it is equal to Y. We said let up there. Okay, so now we're going to have 2y. Then we're going to have 2y. Then the reason will be the exterior angle of triangle OHF. Right. Okay, let's proceed now. Then if we can adding angle O1 plus angle O2, that will give us what? Angle O1, it is equal to 2x. Angle O2, that is equal to 2y. So it means O1, that will be 2x, plus O2, that will be 2y. Right? Then angle O1, that is the whole of this angle, which gives us GOF. Then we have G angle OF, which gives us 2. And then looking at this, we have 2 as our common factor. Then we're going to take out 2. Then we're going to have x plus y. Now, what is our x plus y? Our x, we said let it be equal to h1. Then we have 2 into h1 plus h2. And then in that case, now h1 and h2, it is the whole of h, which is made of G angle HF. Then that will be equal to 2GH F. 2G angle G HF. That is equal to that. And we can also take a look at the angles. So Let's look at it. We have a circle, and then we have this type of a theorem. They say the angle at the center, or the angle subtended by the arc at the center, it's twice the angle subtended by that. Okay, let's measure it. We have 29, and then we have 58. Let's see if we can take 58. If we can say 29,4 multiplied by 2, which is angle at the center, it gives us 58. And then, okay, let's look at another case where we're going to have we're going to have this type of a situation. We have angle subtended by the arc, and then we have an arc here. Okay, let's measure the angle and see if the theorem is telling the truth. We have 34, the angle at the center, it is 2 times, then 38,4. When we multiply it by 2, it's 2 times the angle at the circumference. When we multiply it by 2, we get 76,8. That means whatever the proof is, it's valid. The statement is true that the angle at the center, it is 2 times.